So what we're talking about today are hydrates. Hydrates are a special kind of ionic compound. And you could probably take a guess just from the name or maybe from the PowerPoint background, what do hydrates have in them? Water. So if we start with the definition, a hydrate is a substance or a compound that has water as part of the crystalline structure. One thing I should point out here is that a hydrated compound does not necessarily look like it has water in it. Water is part of the crystal structure. So when you look at a hydrated compound, it's still going to be a solid. Many of them are either like crystals in form or like a powder. We're going to do a lab with one a little bit later, probably next week. And when you look at it, it looks like any other compound. It looks like any other ionic substance. Think about what table salt looks like. A hydrated compound really doesn't appear any different. It's not like you can see the water. Water is part of the structure inside the compound. The way that you write it out looks like this. So you would start with your normal part of your formula. CuSO4 should look pretty familiar by now. And then you put a dot. And then you put the number of water molecules that are part of the crystal structure. That dot is not a multiplication dot. It's like a separating dot. It's just there to show you that water is part of this crystal structure. It is not multiplication. Then if you were going to name this compound, you need to include the water in the name. So the first part of the name is just like what we're used to. It would be copper 2 sulfate. We'd have to look up sulfate on our polyatomic list. Copper is a transition metal, so we'd have to figure out what charge it has. And then at the end of it, you include the name for the water. And that would be pentahydrate. Why is it penta? Because there's 5. So we do have to know some prefixes. Think like polygons, like geometry. We have to know some of those prefixes to do this. But it's not adding that much more to what we already know. So what prefixes do we need? Here are the ones that you will see most often. One is mono, like somebody talking in a monotone voice would be one tone. 2 is di, 3 is tri. Those you're probably used to. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona, kind of sounds like 9. 10 is deca, like a decade has 10 years. I skipped 11 because you really don't see it, oddly enough, so we don't need to know it. And then occasionally you will see 12, and 12 is dodeca. So you can put these prefixes on your list of things to memorize along with your Roman numerals if you don't know those already. But like I said, probably half of the things or more on this list you already know. You probably already know that penta is 5, that hexa is 6. So there's really only a handful from here that you might have to memorize for the first time. So let's do some naming practice. Name the following: Na2CO3.H2O. What would be the first thing we write down? Sodium. Then we've got CO3. We're going to have to look that up. Carbonate. Do we have a transition metal here? No. So we have sodium carbonate. And then how many waters are there? One. So we would say monohydrate. Sodium carbonate monohydrate. What would be the first part of this name? Barium. Bromide. Make sure you change the ending to IDE. And how many waters? 4, so this would be tetra. Barium bromide tetrahydrate.
What's the purpose of the S in parentheses?
Oh, that tells you it's a solid.
Okay.
The S tells you it's a solid. How about this one? Magnesium sulfate. And the end? Heptahydrate. Magnesium sulfate heptahydrate. You can also go the other direction and write the formulas from the names. Now you're going to have to check your charges. We need the formula for calcium chloride dihydrate. First part is Ca, then what? Cl2 dot 2H2O. CaCl2 dot 2H2O. Let's try another one. Sodium sulfate decahydrate.
Do you have to put the S at the end?
No, you don't have to put the S at the end. How many sodiums do you need? 2. So Na2, SO4, and how many waters? 10. Na2SO4 dot 10H2O. One more of these. Barium hydroxide octahydrate. Hopefully you ended up with BaOH in parentheses 2 dot H2O. Questions so far? Okay, one other thing that we're going to point out that you can do with these compounds is determine the percent of the compound that is water. So this is pretty much exactly what we did last week, what you did in your bell ringer this morning, percent composition, except we'd like to know what percent was water. So if you were going to use our part over total formula for percent composition, the part that we want would be the mass that is water divided by the total mass of the hydrate times 100. Let's do a few examples of these. Here's our first compound, and we would like to find what percent of this compound is water. What should we do first?
Solve it.
How?
I don't know, you tell us.
Okay, you're being recorded for posterity here. Just so you know. What do we need to do first? Find the mass of the hydrate. So we need to add up all of the parts here. And this is where it's important that you remember that that dot is not a multiplication dot. We're still just adding all of the parts. So we would need to look up 1 magnesium, 1 sulfur. How many oxygens do we need? 4 for the first part. How many for the second part? 7. Because there's 7 waters. And how many hydrogens altogether? 14. Now here's a little shortcut for you. If you know the mass of 1 water, that will make these problems much, much shorter for you. Because instead of adding up 4 oxygens plus 7 oxygens plus 14 hydrogens, you can shorten that process by adding 7 waters. So if you know the mass of water, then you just have to take care of the first part individually, and you can do the water kind of as a group. So what would the mass of 1 water be? You'd have 2 hydrogens plus 1 oxygen. So what do you get here for 1 water? 18.02. The mass of 1 water is 18.02. That will always be the same. So if you know the mass of 1 water, then all you have to do is take that times however many waters you have. How many waters do we have in this one? 7. Then for the mass of the hydrate, you would take that amount and add it to the beginning of the compound. So we would have We have our 24.31, that's our magnesium right here. 32.07 is our sulfur. 4 times 16 is the 4 oxygens. 7 times 18.02 is the 7 waters. Add all those things together, you should get 246.51 grams per mole. Then we need the mass of the water by itself. 7 times 18.02 is 126.14 grams per mole. And we have our part and we have our total. So the last thing we need to do is divide. So 126.14 divided by 246.51 times by 100 to make it a percent. Check your sig figs. How many should we keep? 5 total. There's 5 sig figs in each of those numbers. So your percent water comes out to be 51.168%. The part that is water divided by the total times by 100. Let's try another one. CaCl2.2H2O. Find the percent water. You'll need to know the part that is water and the total mass of the compound. If you remember that the mass of 1 water is 18.02, take that times 2 because there's 2 waters in this formula. That's 36.04. Then you need to find the total mass of the compound. So you would add up 40.08, that's 1 calcium. 2 times 35.45 is 2 chlorines. 36.04 is the mass of the water that we already found. Altogether, you get 147.02 grams per mole. To find the percent water, you divide the mass of the water by the mass of the compound, times by 100. Check your sig figs. How many should we keep? 4. And you end up with 24.51%. Let's try one more. Barium hydroxide, .8H2O. First thing you do is find the mass of the water. If you remember that one water is 18.02, then you just need to take that times 8, which is 144.16. Then you need to find the total mass of the hydrate. So you would have 1 barium, that's 137.33, plus 2 oxygens. Remember, it's got to be 2 because the 2 on the outside of the parentheses gets distributed to what's on the inside. Plus 2 hydrogens, plus the water, which was 144.16. You should get 315.51 grams per mole. And then you just need to divide. Take the water divided by the compound, times by 100. How many sig figs should we keep? 5. You should get 45.691.